Good evening, ladies and gentlemen, and welcome to the General Society of Mechanics and Tradesmen of the City of New York and the 7th season of the General Society Artisan Lecture Series. This program is supported in part by public funds from the New York City Department of Cultural Affairs in partnership with the City Council and the Friends of the Artisan Lecture Series. And for those of you not familiar with the Society, I just would like to briefly tell you about it. We were founded in 1785 by the skilled craftsmen of the city. Artisans who represented 22 different trades, including carpenters, saddlers, tailors, and silversmiths, among others. Today, our 232-year-old organization continues to serve the people of the City of New York through its educational, cultural, and philanthropic programs, which include our Tuition-Free Mechanics Institute, our Mossman Lock Collection, which is upstairs. There's over 350 locks and keys going back to the late 19th and early 20th century. We have the General Society Library and our nearly 2-century-old lecture series, of which the Artisan series is a part. And you'll find additional information on the blue postcards on your seats. The space you are in tonight is the library of the General Society. Founded in 1820, it is the second oldest circulating library in New York City, and you can join for as little as $35, but you must be a senior. And, and we check. So tonight we gather once more to pay tribute to the art of craftsmanship. The Artisan Lecture Series has committed itself to giving voice to internationally known artisans who will talk about the intricacies of their specialized crafts. The mission of the Artisan Lecture Series is to promote the work and art of skilled craftsmen, to assist in ensuring that their unique knowledge is understood and carried forth for generations to come. The Artisan Lecture Series is co-curated by Rhett Butler, owner and founder of E.R. Butler, and Jean Wiart, artisan of fine ornamental metalwork and the original curator of the Artisan Lecture Series. It is now my pleasure this evening to welcome Jean Wiart, who will introduce our speaker this evening. Thank you.
Good evening. Bear with my accent. I met with James Swan late January of this year when the Roebling chapter of the Society for Industrial Archaeology toured the shop of LMC where I work, Les Métalliers Champenois, in Paterson, New Jersey, while attending the Great Falls Symposium of this society. At the end of a repoussé demonstration I made, one person stood there quietly and asked me precise questions about the materials, the alloy, the tools, and so on. And this person was James Swan. Didn't I know at that time that I was facing many talented persons in one? Indeed, James Swan is known as a legend in the cycling community, as he is or was a gifted bike racer, a bicycle wheel builder for 14 years, a bicycle shop owner over 17 years, involved in many cycling associations of all kinds. Jamie, as his friends call him, gave me his card, and through our first email exchanges, I learned that Jamie Swan carries deep in him the love of tools and shop machineries. Well, such a close match to my own passion. From then on, I read articles about the professional life of Jamie Swan and all of the association he belongs to, the Long Island Metal Workers Society, the Watts Campbell Preservation Society, the early American Industry Association, the Long Island Antique Tool Collector Association, and of course the Society for Industrial Archaeology that I mentioned earlier. And there may be more, I do not know. Today, James Swan is devoting time and experience to the transmission of his immense knowledge in mechanics and people at the Webb Institute in Glen Cove, New York. And this is quite of a twist of destiny that today's lecture occurs at the General Society of Mechanics and Tradesmen, in which William Webb, founder of the Webb Institute, was an active General Society member who generously presented us with a large, remarkable painting titled From Riches to Poverty that hangs here in our assembly room. And we will see it together, this painting, at the end of the evening. Furthermore, according to Mr. Webb's intention, the General Society was to have had a member assigned as a trustee to the Webb's Academy and Home for Shipbuilders since its inception in 1889. No other place, indeed, would have been more fitting than this one to welcome the lecture of Mr. James Swan. Please join me in a big round of applause to welcome Jamie Swan.
Thank you, Maestro. You're too kind. I'm speechless. It's not a good way to be right now, is it? I have to start off by thanking the Society, the General Society, for having me. This is wonderful. You've made me feel so much at home. Victoria Dingell, and particularly Karen Taylor, who has shepherded me. Where's Karen? Karen, so graciously and efficiently shepherded me through this process of coming here tonight and speaking in front of you. I'm not going. Most of the audience are friends and family, so I'm not going to attempt to acknowledge each of you because I know I'll forget somebody and be mortified later on. But many frame builders, bike advocates in the room. We have a large contingent from Webb Institute. Unfortunately, our president, Keith Michelle, can't be here, but his wonderful wife, Peggy Michelle, is here among us. Hi, Peggy, thanks for coming. And my boss, Neil Gallagher, and a large contingent of the trustees. I have brought with me tonight, Webb Institute would like to donate to the Society these 3 books that are a biography of William Webb, and then 2 books about the history of the school. So on behalf of Webb Institute. Thank you so much. This is going to be a slightly unorthodox display. I was with a friend of mine last weekend who gives a lot of PowerPoints, and he said, you know, the optimal number of slides is about 20. I have 225 slides. It's going to be more like a movie. Speaking of movies, I'm going to start off by showing, hopefully I'm going to start off by showing a video. How do I minimize this? Thank you. We were having technical difficulties later. Okay, great, thanks. I won't start it yet. The General Society suggests that presenters show a short video. The only video that I have available was made for the purpose of promoting a hand-built bicycle show that was promoted by several friends of mine here in Brooklyn a few years back, and they had a cooperative agreement with an industrial design website called Core 77, and Core 77 commissioned a video on me, and it was produced by Isaac Schell, who's here with us tonight. Bravo, Isaac, you can take a bow. So it's more about me than the work, so I thought I would play it first and get it out of the way and then launch into my spiel. So without further ado, we'll play. I've always been interested in tools. I'm sort of a tool junkie. I have done a lot of reading about industrial history. I'm a member of the Early American Industries Association, the Society for Industrial Archaeology. I've been active in the Long Island Antique Tool Collectors Association for many years. So I've just always been immersed in the topic of tools. guess all the kids in the neighborhood have a bike. Everybody starts out riding around on a bike. In the early 70s, I was still a teenager, and the bike boom struck, and everyone got a 10-speed bike, and I got one, and I just was hooked. I never turned back. I went to an alternative high school, and one of the kids in the school was my buddy, and he got a job at a local bike shop, and he told me that if I went down there, they'd probably hire me too. I became aware of the better bikes. I saw the full campy bikes and the high-end lugged frames, and I was just so enamored with the top quality bikes. And I also started going around to a lot of the pro shops around Long Island, and one of them, I kind of hit it off with the mechanic there, and he and I took out, we both decided to start racing together, so we took out our racing licenses at the same time, and I hung around there all the time, and before too long they offered me a job, and I quit the other shop. That's how I got started on bike racing. I built my first bike frame in 1981. I was done with college. I knew a bit about metalworking from school. A book came out about how to build your own bike frame, and it was written by a guy he was not a frame builder. He was an engineer and built one bike and wrote a book, took pictures and wrote a book as he was doing it. It demystified the thing, and it also made me aware that I didn't need a lot of fancy equipment. If you have a workbench with a vise, you have an oxyacetylene torch, hacksaw, files, a few other tools, which I actually had a lot more than that, but I was actively racing on the track at that time, so I designed a bike specifically for that track, and it worked really, really well. It was just so thrilling to build this thing and then get on it and ride on it and race and win races. It was a real kick for me. I guess the overview is, does it do what the owner wants it to do? There's so many different types of cycling, so the bike needs to be properly engineered for that application. It should fit well. Some of the subtleties of geometry in terms of handling and weight distribution and balance. The integrity of fabrication is a big one with me. The joining process, be it welding or brazing or whatever, not compromise the health of the metal when you're doing that joining process, so it takes a bit of skill to do that properly. And then it should look good. I opened Centerport Cycles in 1990, and I operated that shop for over 17 years. At the beginning, I was very ambitious and bright-eyed and bushy-tailed. And as the years went by, I think I became disillusioned. I was realizing that I was never really going to make much money at it. I was having a lot of fun. I really enjoy it. My shop was kind of like a clubhouse, which is a bad way to run a bike shop. And I knew what I needed to do to make it successful, and it was just, I didn't have the stomach for it. I just kind of got demoralized, and I had it in the back of my mind for many years that I wanted to try to get a job doing something using my mechanical skills outside of the business world. I currently work at Webb Institute. It's a school of naval architecture and marine engineering. My job title is, it's a mouthful, Mechanical Engineering Laboratory Technician / Machinist. I support the various laboratories there, so I handle the mechanical side, maintaining them, building things for new experiments, things for research, mechanical devices for senior theses. And also we have a marine engineering laboratory, so I support that lab as well. I do a little teaching. I teach a little welding class, just simple stick welding and flame cutting. And then I teach some machine shop classes in lathe work, milling, and CNC milling. Being a mentor is not something that I decided to do. It's not a major theme in my life, but maybe it's starting to be that. I'm getting older, and I've had a lot of experience in a variety of different things, and more and more I find myself helping younger people, frame builders, bike racers, people who want to do machining, wheel building, almost anything that I have expertise at. I guess more and more that's starting to be my lot in life, I guess. Certainly in the frame building world, I'm known as somebody with expertise in the machining side of it, and get a lot of requests for advice. I've made myself kind of useful helping people that way. Machine tools like a lathe or a mill will outlive whoever's using them, so we're kind of just stewards for these machines, and they find homes in these small shops, and that's a really good thing, I think.
Isaac Shell.
See if I can do this.
8 o'clock, and there's the
Okay. So I've shown the video. The first thing I want to start off with, the overview. I'm going to make an argument that there is a precedent for the vocation of making bicycle frames in the city of New York. And then I want to walk you guys through the process step by step. But I've kind of jumped out the last two items, lug carving and randonneuring bikes. I've pulled them out of sequence because they're very, very rich in content and many, many slides, and I was concerned that my presentation would stay within the time limits. So I'm going to run you through the process of how to make a bike, and then go back to some of those things that are really more almost ancillary. And if need be, if we run out of time, if I get to the bell lap, someone will wave the white flag for me, and I'll just pump through the slides and not necessarily talk so much, just so you can see some of the images. So we think of bicycle racing as sort of a Eurocentric. Is it not getting me? Are people hearing me? Oh, thank you. They take good care of me here. Great. So I think most people think of bicycle racing as kind of a Eurocentric sport, but at the turn of the 20th century, it was probably much bigger in America than in Europe, and the most popular area for bicycle racing was New York City. Bicycle racing, we have to remember that this was before the automobile, so these bicycles went so fast that people were only used to, like, the only thing that went fast was a horse. So bicycle racing was a huge spectator sport, and the racing was done then on banked tracks like this, made out of wood. It's called a velodrome. And there were, I don't know exactly how many, but there was a very large number of velodromes in New York City. There was one, many of them were set up in armories. There was a big one at Coney Island, and the granddaddy of them all was Madison Square Garden. This is the garden. This is the kind of a cartoon. The sport, the big sport that happened, that I need to stand still. Yeah. I actually don't like the microphone. I don't like to hear myself. Sorry. The sport of 6-day bike racing started in Madison Square Garden, and originally it was like this endurance contest where individual riders did their best to just go round and round day and night to cover the maximum number of distance, the amount of distance. The rider that did the most mileage in the 6 days was the winner. So they might get off and rest and eat, but it was a brutal thing, and they weren't permitted to race on the Sabbath, so the whole thing came to its culmination on Saturday night. Over the years, that format evolved so that 6-day bike racing still occurs, but now they just do it in the evening for 6 days straight, and it's very popular in Europe. And it's done by teams of 2 riders, and they take turns covering the distance. And they actually, the modern format, they have quite a few different kinds of races in the night. But the feature event is a team race where these 2 riders take turns covering the distance, and they take turns. When one rider takes over from the other, they either grab the rider by the back of their shorts, it's a little, they call it a chucking tool, or they grab hand to hand and actually launch their partner into the fray. And so one guy is racing and the other guy is resting at the top of the track, and they take turns. And that format is all the major cities of, well, not all, many of the major cities of Europe still will have an annual indoor, it's a winter sport, so they'll have an annual 6-day race, and the feature event is still called a Madison. So that's a long way of telling you that bike racing happened here in this. Where there is bike racing, there are frame builders nearby. This is a New York City frame builder named John Pop Brennan on the infield of Madison Square Garden. He's the guy with the cap. He started his career building chandeliers and segued into making bicycle frames, transferred those skills. Another prominent frame builder of the early 20th century in New York City was Alvin Drysdale. And this is kind of interesting. His former address was about a mile from here. He was building bicycle frames in Manhattan. Another huge frame builder was a guy named Dick Power. You see that it says Sunnyside, Long Island. He was out in Queens. He had several different locations. A friend of our community, many of the people in this room are friends with a guy named Eddie Albert. He's really quite a scholar on New York City bike racing and a collector of bike racing and frame builders, and he's a collector of New York City bikes. And he has written a wonderful book about Dick Power. Dick Power's life story was really, really interesting, way beyond the context of bike racing and frames. Eddie has yet to get the book published. The title of the book is A Dark Day in Sunnyside. I think the kick for Eddie was the research, and he doesn't even seem to care about getting the book published, but I wish that he would, because it's a great story. Another Dick Power. So let's talk about the materials that bicycle frames are made out of. I make bicycle frames out of steel. It's totally out of step with the bicycle industry today. The best bikes today are made out of carbon fiber. This slide illustrates how light they are. The young girl is balancing this bike on her hands. I'm not a fan of carbon fiber. I actually believe that the insiders in the bicycle industry are not a fan of carbon fiber, but they are selling it hand over fist. Why are they doing that? Because it's easy to manufacture and it's easy to sell. The reason that it sells well is because it's lighter than a steel bike. The very lightest carbon fiber bike versus the very lightest steel bike, the difference is about a pound. If you put a rider on there and you measure the whole weight of the vehicle, the difference, the aggregate weight difference is less than 1%. Sometimes it can be far less, depending on the rider, if the rider might need to lose a little weight. So the carbon fiber has an Achilles heel. It is prone to failure, and carbon fiber bikes are failing all the time. The reason they fail, the fibers themselves, this shows some actual carbon fibers. They're referred to as tows, T-O-W. That term goes back to the making of rope and linen. Have you ever heard the term to describe someone with blonde hair, a towhead? They're talking about their hair looks like the blonde fibers from a flax plant that was used to make linen. So even today, they call the fibers in the carbon fiber tow. It's incredibly strong in tension. It's very, very light, has a very high strength-to-weight ratio. But the thing is that you can't make a bicycle frame or an aircraft or rocket ship out of these limp, it looks like human hair. You need to hold it together. They hold it together with epoxy. The epoxy is its Achilles heel. As long as it stays intact, it's very happy. If you get a scratch or a nick on it, that scratch or nick can quickly propagate into a failure, and when it fails without warning. It fails abruptly. Any bicycle frame can break when you're riding it. Steel bikes break, aluminum bikes, titanium bikes, they all break. Most of the metal bikes give you some warning. You're riding along and you feel something a little funny. What's going on here? It's making a strange noise. And you get off and say, oh crap, my bike is breaking. A carbon fiber bike does not do that. It just lets go. We had a rider out on Long Island who lost his life. When the head tube of a bike becomes disconnected and the front wheel goes away, unless you're going at a crawl, it has tragic consequences. So I build bike frames out of steel. I sincerely believe that it's the best fabric. It's also what I grew up with. I just love it, and it's like a passionate thing too. The particular alloy of steel that's used to make bicycles is called 4130. Steel is an alloy of iron and carbon. ironically enough. Any steel is going to have some trace of carbon. There's often other alloying agents. In the case of the bicycle tubing, they add a little bit of chromium and a little bit of molybdenum and probably some other stuff, and it makes it very, very tough and has high tensile strength. So 4130. The bike frames that the tubes that we use to make bikes have a unique feature. The inside diameter changes over the length of the tube. It's thicker, they call it budding. The tube is thicker at the ends where it needs the strength for the joining process and thinner in the middle to save weight and make it resilient. How do they do that? I'm glad you asked. It was a process patented in 1894, I think, by a guy named John Reynolds in England. They have a mandrel. You see here a mandrel, and the tube is squashed down over that mandrel. It's a drawing bench, and they pull the tube and the mandrel through that ring-looking thing, and it squashes it down onto the mandrel, and then now the tube has the proper shape. How do you get the mandrel out? They pull it out, and it flares out the end of the tube, and then there's another process where they put the tube through another die and squashes it back down. So that's budded tubing has been around for all that time. This is a sticker that would be put on a Reynolds bike frame tube. Reynolds bicycle frames with Reynolds tubes have won 27 Tours de France, although not so much lately. The last Tour de France won on a steel bike was Miguel Indurain, and I don't know if it was a Reynolds bike, but that was 1994. And here is Senor Indurain resplendent in his maillot jaune. The frame builder will select, the frames come in a variety, the tubes come in a variety of different lengths and gauges, diameters and wall thicknesses, and the frame builder has to make decisions about what to select. This is a specification. The 28.6 is the diameter of the tube, and then the 1.0 and 0.0 are the wall thicknesses of the center and the butts. That's a really, really, all my frame building brothers are saying, man, that's a heavy tube. That's a very, very thick walled tube, but it was the best image I could find. So let's name the tubes in a bike frame so you know what I'm talking about going forward. We have a top tube, down tube, seat tube, head tube, fork blades. There's also a steerer tube connected to the fork that they don't mention. Chain stays, seat stays, the bottom bracket shell. And we need some other little bits to hold it all together. The three things on the right are called lugs. They are like plumbing fittings where the pipes plug in. The bottom bracket shell where the cranks would go through, a fork crown, dropouts that hold the wheel, front and rear dropouts. The things on the back left are called top eyes. They're brazed into the top of the seat stays to give it a nice ornamental look, and then various other braze-ons that are put on the frame to make it hold the parts. The joining process that we use is called brazing. You can certainly weld together chromoly tubing. Lots of bicycles are made today by TIG welding chromoly tubing. Many, many thousands of aircraft were built by gas welding chromoly tubing, but the traditional method of building bicycles is brazing. Brazing differs from welding in that when you weld something, you're melting the two pieces of parent metal. You can see these two pieces connected, and the edges of them have been melted, and we're creating a pool of molten, in this case, steel. So you're melting the two edges of the steel. Now you have a molten puddle. When it cools, it coalesces into one piece of metal. When we braze something, we don't melt the parent metal. We don't melt the steel. The word brazing comes from brass. We use a dissimilar metal with a lower melting temperature, and we literally gluing the pieces of steel together. I need a drink. We heat up the parent metal. It becomes chemically active, and we introduce some brass or silver filler rod. It flows into the gaps, and it actually goes into, there's pores in a piece of steel. You can't see them, but there's microscopic pores. And the filler, just the same way glue works, it's going into pores. That's all it's doing is infiltrating the pores in the material. And then the filler material cools, and it sticks together. I brazed frames for years before I found that out, and I just couldn't believe it was true. I always assumed that there was like a sharing of electrons between the steel and the brass, that they were like making a figure eight. Neil is looking at me with a knowing look, of course. So we braze bikes together. This is showing some, we use brass brazing rod. This is enough brass brazing rod to last all the frame builders in the world a few years. And we use silver brazing. The brass comes in rods and the silver comes in a wire spool. And we're showing some flux. There's flux put on the joints to keep it clean during the process. In the early days, the brazing was done in like a blacksmith's hearth. They call it forge brazing, but really, hearth brazing, but to me, it's done in a forge. And luckily, we have, this is the only image I could find. This is from a book published in about 1900 of a compilation of articles from Iron Age magazine. So we braze the frames together. Okay, frame builders, $10 to whoever can name the builder. Come on, Simon. Ron Cooper. Yeah. So the thing is, we have two methods of brazing frames together. One of them is called sweat brazing, and the other would be called fillet brazing. Sweat brazing is where you have a tiny slot at, a gap. We heat up the joint, introduce the filler, and the filler gets sucked in by capillary action. I'm sure that some of you, maybe all of you, have seen this is the way plumbing pipe is assembled. You heat up the joint and you introduce the solder, and it just flows in there kind of magically. And I'm not sure that science has fully explained why. But anyway, that's sweat brazing. You also can just braze a bike together without lugs, and you can, instead of having that fitting where the filler flows by capillary action, we just build up a fillet. We melt and it's typically done with brass. It's much more viscous when it's molten. So we build up those fillets with brass. So this shows a head tube, a down tube, and a top tube that have been fillet brazed together. And there are advantages to that because you're not constrained by the angles that the lugs might hold you to. There's yet one other method that we use. It's kind of a hybrid. It's called ring brazing. This shows a couple of top eyes that need to be brazed into the end of the seat stays. It's very difficult. You're going to have like no lip or a shoulder to introduce the filler. So what we do is make a ring out of the brazing rod. That's only that big. But we take some brazing rod and wrap it around the rod and make kind of like a spring-looking thing. We stick it inside that joint, flux it up, and then heat it up and wait. And the molten filler appears at the joint. We know that it's flown through the whole joint. And that process of ring brazing is used industrially. It's very, very common. And in fact, the Japanese bicycle industry started building whole bikes that way. And they were quite competitive, if not dominant, in the 1980s. They made, lugged steel bikes were still popular. The Japanese were setting the industry on its heels. So this is, you can see the brazing material. This is post-brazing. You can see the slight little rings of silver that has erupted on the edge there. And this is the same thing cleaned up. So those are ready to go on the bike. Those have been ring brazed. The brazing process takes a lot of heat control. We use oxyacetylene torch. The flame is around 5,000 degrees. You can do a lot of damage if you dwell in one spot. So it takes a little bit of practice to control that heat and to get the braze to flow. If the joint is covered with flux, if we overheat that flux and scorch the flux, it turns black and it stops working and you're kind of dead in the water. But if you've done it very, very well, the flux, this is a cool joint post-brazing, but it's covered with flux, and you see how it looks like glaze? This is magnificent. Whoever did this is, usually you'll see a little bit more black, but I was so happy when I found this picture on the internet. Chapeau to whoever did that brazing, but that's well done. So good brazing practice ensures a very strong bike. You're minimizing the disturbance, metallurgical disturbance, and you're trying to control the alignment too. So let's talk about design. If we're going to design a bike, the first thing we need to think about is purpose. Are we going to build a mountain bike? Are we going to build a track racing bike? Are we going to build a bread delivery bike? So the frame builder needs to think about all those parameters. How big are the wheels? How fat are the wheels? What kind of gears is it going to have? What kind of brakes? And have all that in his mind as he moves forward in his design. The next consideration, let me just stop. The types of bikes that I've been building traditionally are what we call cyclist sportif, sport bikes, where it's basically a road bike, but it has slightly wider tires, clearance for fatter tires, and fenders. This is taken in Chianti region of Tuscany, where I did an event called La Roica. It's all on dirt roads that are, the roads are white, the dust is white, and it gets all over the bike, the Strada Bianca. So that's the kind of bikes that I build. But more recently, I've kind of graduated to building I think a more sophisticated bike called a Randonneuring bike. It's similar to a sportive bike, but it has a bunch of other stuff. It has the same even fatter yet tires, fenders, and it has the ability to carry a load in the front, integrated lighting systems. And I'm going to come back. That's like my final thing. I'm going to come back and talk about Randonneuring bikes, but we'll move ahead. So the next thing we need to consider when we're going to design a bike is who's going to ride it. If it's a good bike, it should be made to fit the rider. We didn't evolve to ride bikes. We're not going to adapt our body to the bike. We need to adapt the bike to us. So we need to consider the physical dimensions of the rider and make a bike that's properly fit. So there's two methods. The old school method is to actually take anatomic measurements and transfer those into dimensions. And the more modern method is to put the rider on a stationary adjustable bicycle and manipulate the rider until they look right. And they typically use like a big protractor to measure the angles between the rider's upper leg and lower leg, between their upper leg and their torso. And they'll go where it's called a goniometer. It's just a big, and they have the fitter. I mean, this has become an industry unto itself now, bike fitting. People are spending many, many hundreds of dollars to achieve comfort and efficiency on their bike. And you can go around New York City, there's many people who are earning their living as bike fitters. And it's what money's well spent if they achieve comfort and harmony with their bike. I mean, it's a wonderful thing to go out for a bike ride and nothing hurts. You just feel the bike disappears. So the things that we look at when we are designing a bike to fit a person, there's really very few parameters. The length of the seat tube, the length of the top tube, the length of the stem, and the seat tube angle. So that's factored in. We have purpose, and we have fit, and we design a bike. Most frame builders will commit it to paper, either a CAD drawing or an actual paper drawing. It's not absolutely necessary to draw the bike full scale. Some builders will just make a note of those parameters and move forward. I've been doing it in CAD since Professor Gallagher was so nice as to teach me CAD. So now before we build a bike, I want to just talk about tools a little bit. The biggest and most obvious tool that a frame builder uses is a fixture. Technically, the correct name for it is a fixture. A lot of people say jig. There is a slight difference that I can tell you later if you care. Everybody calls them a jig. I'm going to call it a jig tonight too, but technically it's a fixture. Most frame builders will go out and buy one. A good one is like $3,000, $4,000, $5,000. With me, it's kind of a point of pride to make my own, of course. And my fixture that I have designed has some features that I don't know if anybody else has done, and it works very well, and I'm pleased with it. This is the fixture to build the fork. This is a bending block to bend the fork blades. They come straight, so we want to kind of control how much we bend them, so I've made that. And once I made it, some of my friends who are luminaries in this world, Peter Weigel put the arm on me to make him one, and then Kirk Pacenti said, "Can you make me one too?" So those are out in the world in the hands of big shots. This is a frame alignment gauge, which I'll talk a little bit more about alignment. That's just another little tool. There's probably dozens and dozens of tools that I've made for this. I'm going to talk in a minute about mitering the tubes. We have to cut the tubes so that they fit into each other. So we're seeing here a horizontal milling machine with a rotary table and a tube mitering fixture that holds the tube while we cut it. This is a fork alignment fixture, so we can bolt the fork down and suspend it above an alignment table and check to see that it is straight. These are called radius collars. They're bending mandrels to bend tubing for making some of the racks that we build on Randonneuring bikes. And I've built duplicate sets, both in these. This set was to build these low rider racks, and this set was to build the front rack that I'll show you that's on my bike. When I draw a CAD drawing, I actually wind up with 3 or 4 different drawings for the bike because I just can't pack all the information into one drawing. So this is a drawing that shows me the settings for my fixture. And I'm going to get to the next drawing in a minute. The first step in actually building the bike is we survey the tubes. I've got the tube suspended between V-blocks. If you take a bicycle tube and roll it on the countertop, you'll see that it has like a wobble in it. It's not straight, it's bowed. So what we want to do is locate that bow and put all those bows in plane. You don't want to have one going out this way and one going, pretty soon the bike will be all cockeyed. So like if it's the top tube, you put the bow up or down. So we need to locate the bow. So we put it between a set of V-blocks, put a dial indicator, and spin it until the dial indicator is at its maximum reading. And then just put a little mark there with a Sharpie, and then take the indicator away and draw a line down the whole length of the tube with a Sharpie, a black Sharpie line to locate the high spot in the bow. The next thing we have to do is locate the butts where it transitions from thick to thin. Typically, the tubes are made with a long butt and a short butt, and it's intended so that you trim most of the material off the long butted end. But we want to really know where those butts are. And so we want to mark it on the tube. This is my rig to locate those butts. I'll show you how it works in a minute, but that long rod is going to go inside the tube, and the indicator bears on a little button there. So I've got the indicator zeroed, so the gap right now is 0. And as soon as the tube is placed in between there, it'll read the thickness of the wall of the tube. So this is a tube in place. And you can see that the indicator has moved off. Look here, it's at 12 o'clock. It's moved off there to 25 thousandths or something. And we slide it along and we locate what you're seeing there is where everything to the left is a uniform diameter, then between the two marks is tapering, and everything to the right is a uniform thin diameter. So we're going to have that on both ends of the tube, and we're going to say, well, I need this tube to be 56 centimeters, so we're going to decide how much to trim off each end. This is a tube mitering drawing that shows me the angles that I have to miter them at and the center-to-center tube dimensions. So this back to the mitering fixture, we use the milling machine to actually cut those shapes, the copes. You can do that with a file, and many frame builders do, but as a machinist, I kind of like to do it in a milling machine, and it's very, very accurate that way, or hopefully it is. So we've got all the tubes mitered, we stick the frame in the jig. Now we have to introduce the lugs. This is an example. I need the pointer. I should be using it all along, but see this gap right here? The lugs come at certain angles. Like that probably says 60, and what I needed on this particular frame was 63 or 4. What we typically do is bend the lugs to get the angle that we want, but you can't bend them too far. The modern lugs are investment cast. The way we bend them is put heavy steel bars in place of the tubes and just use a lever and then take a protractor and measure between the bars to see if we get the angle that we're looking for. This one was too far off to bend it. It just would have been a mess. So instead of bending it, I just chopped the whole spigot off of it and fabricated a new spigot. I've taken a piece of chromoly tubing and I've mitered it to fit on there. And now I've fillet brazed it in place. And now I've sculpted it to look the same way as it was supposed to look. But it was, like a day lost to just get a really good fit up. We frequently pin the tubes into the lugs. The pin of choice is a 4-penny finish nail. As we're working and taking it apart and putting it back together, we want to just make sure everything falls back exactly where we want it. So pins are common, more pins. We flux everything up and we put it in the jig. Now we're going to start brazing the frame. The first step in brazing the frame is that we just put small, tiny dots of brazing material. We don't just braze a whole joint. They're called tacks. And we would just put them on the lug points, like right there, there, maybe one right in the front. And we put all of our tacks down the center line of the bike. They're all in plane. When you melt metal, it expands. And when it cools, it contracts. So when you introduce molten metal between two pieces of a frame, it's hot, and as soon as it cools, it shrinks and it pulls. So the thing is that if we put a tack off to one side or the other, it would pull the frame out of alignment. So we put all our tacks down the center plane, and we just kind of tie the frame together. But it's now you can take it out of the jig, but it's not really, it's not a frame yet, it's just tacked. So this shows the tacks, and we put it on an alignment table, and we're going to check to see if the frame is straight. Dial indicator in the middle. What we're looking for on this set of bench centers is holding the head tube horizontal to the table, and we put a jack under the middle of the seat tube, so the center line of the seat tube and the center line of the head tube are equidistant from that table. Now we want to see if that seat tube is parallel to the table, and that's critical. A lot of frame builders will refer to that as head tube twist, but in this case, it's more like seat tube twist, the head tube being our datum. So we put an indicator over the jack, zero it, and then move it down, and I'm proud to say it's still at 0. And we move it up, and it's still at 0. So if we've done our job right, it's fine. We can go ahead and braze it. If it's a little off, we cold set it on the table. And this is the opportunity for the frame builder to change the shape of that frame and get it right. Many, many frame builders are not controlling the process this way. They'll go ahead and braze the whole frame, and then it's crooked, and then they try to cold set it, and it's a fool's game. You're basically going to build a bad bike. So at this stage, you can manipulate the frame to your heart's content because it's just got these little tiny dots on the tips of the lugs, and those tips of the lugs are kind of flexible, you know, so you can get it just how you want it and then braze it. We don't put it back in the jig to finish brazing it. Well, we just put it in a regular bicycle repair stand, and we have to be really, really conscious of how we flow that brazing material into the joints. I think this is probably the most challenging part of frame building. It certainly is for me. If you get too much material flowing around to one side of the frame and it's not balanced on the other side and it starts to cool, the bike pulls that way and you're out of control. You'll never get it back. So every builder has a brazing sequence, a way that they go about it to try to, please control. It's like at that point you've done hours and hours of work, weeks of work, and now you threw everything up in the air and you're going to see where it lands. And then you put it back on the table, and hopefully it's straight. A lot of the traditional builders will put the seat stays on afterwards. So this is me jigging up a set of seat stays. That's the seat stay brazed in place. Then once you've finished brazing it, we clean it up and we start filing everything to make it look nice. These are the dropouts where I've carefully sculpted the transitions into the dropouts. We're also going to, now after the frame is brazed, there's a whole bunch of little bits that need to be brazed on. This is a chainstay bridge that I made from scratch. A different chainstay bridge, and this one is on that bike right there, and it's carefully curved to follow the shape of the fender, and it has a braze-on built into it to hold the fender. So putting on like little mudguard eyes and stuff, this is a method that I developed to keep those straight and in line. We're using a V-block, and that's not one rod. So a lot of guys will use one rod in that situation, and then the rod is trapped. So then they'll hacksaw the rod and have to get it out. I was like, oh, this is stupid. Every time I have to rethread the rod. So I just took the rod and hacksawed it in half ahead of time and clamp it in a V-block like that. And I have a whole drawer full of many, many different little lengths of those rods that I can use for different widths. And the weight of the V-block holds it down. And you almost, like if a guy just puts a rod across there, then they're going to hang a weight on it. So my V-block is my weight. So I thought that was a minor stroke of smartness. This thing is a soak tank. It's just a stainless steel tank that's big enough to put the whole bike frame in it. It has a heater element from like a hot water heater. We bring that water in the tank up to 180 degrees, and it gets the flux off really quickly and cleans the frame very, very well. And that was purchased from the estate of our recently fallen brother of the torch, Ezra Caldwell, who built under the name Fast Boy up in Harlem. Great guy who has passed on, but I am honored to be using his tool, and I think of him. This other big gray box here is a sandblast cabinet. We use glass beads, so after you soak the flux off, you can put the frame in there and blast it with an abrasive media and get off the braze flash and clean it up further. One of the things that some of the frame builders who are trying to build really refined bikes will, after the bike is all brazed up, we thin the lugs. We file the surface of the lugs to get them thinner and thinner. If you look at a bike where the lugs haven't been thinned, you'll see that the shoreline of the edge of them is thicker in certain areas and thinner. If you've bent a lug, then you've create very, very thick spots and thin spots. So at least good form to file it so that all the lug shorelines look uniform. But really, the discriminating buyer of this kind of bike wants you to make them fag paper thin, just thin them right down till a blade edge. And it's hard to do. This kind of shows the lower lug is pretty well thinned, and the upper one, I think you can see that it's, I haven't touched it yet, and it's very fat here, and it's kind of fat there. So it's a lot of hours work in thinning lugs, but it's good form if you want to build a fine bike. So we're done building a bike, and now how are we doing for time? Anybody looking at the clock? Karen? I'm good for a little while? Okay, thanks. So now I want to go off on a tangent of discussing lugs and the art of lug cutting and some of the alternatives to lugs. This is from a catalog from 1900. The lugs, these early lugs look like pipe fittings. They're not very artistically rendered. But very quickly, the industry decided to kind of chop the sides off, kind of scallop them, and they look nicer. They have, this is what we refer to as a single point lug, and that's a very popular and common size, shape. A French company, Nervex, started offering many different styles of lugs, more Nervex lugs, more Nervex lugs. These are cast lugs. All those previous lugs were made out of sheet metal by a bulge forming process. So then there was much experimentation in making sand castings, which were very rough. All of these early lugs were rough, and the frame builders, to varying degrees, would dress the lugs, file the surface of them to clean them up, file the edges, file the shorelines. The whole lug thing is an opportunity for frame builders for some artistic expression. We can make the bike look nice or not so nice. And it's easy enough to just take these lugs out of a box and braze the bike together. And that's certainly what happened in the big factories. You're not going to find a bike from the heyday of lugged steel construction, a Raleigh or a Peugeot Motobacan, with lugs where anybody did anything more than take them out of the box and braze them together. And you see plenty of frame builders today who are working for a price point. If you're trying to sell a bike for a cheap price, you just can't be spending any time. You need to just take the lugs out of the box and braze the bike together, and there's nothing wrong with that. But I like to amuse myself with sculpting the lugs and doing some artistic things, and I think a lot of other frame builders do, and you have to charge more. This is kind of an extreme case. A lot of these frame builders are not, they don't have any artistic training, so a lot of this lug cutting, it kind of falls under the heading of folk art, or maybe even outsider art. One thing with shaping these lugs, I think that it's important that we consider the whole bike and try to look at each element and have some sort of a cohesive motif. You shouldn't have something very ornamented here and then something kind of austere and Shaker-esque over there. It should present a uniform kind of a motif, in my opinion. Another thing, a cat named Grant Peterson, who's kind of a luminary in this world, he once suggested that every frame builder who's doing this kind of work should strive to make their bike unique. It should be artistically different than the next guy's. And his thesis was that if we should find one of these bikes in a garbage dump 100 years from now and all the paint has rusted off it, we should be able to, a knowledgeable person should be able to look at the bike and say, Jamie Swan built this, or Peter Weigel built this. So those thoughts resonate with me. So anyway, let's show some of the things. This lug cutting thing was very popular in the 50s and the 60s, and particularly in England. And then it kind of died out. The bike boom occurred in the early 70s, and those companies were selling bikes. Like all of a sudden, every high school and college kid in America needed a 10-speed bike. And the factories went from the production amplified by 1,000%, and nobody was thinking about fine lug work. Just get the bikes done and get them over to the United States. So it kind of died out, but there were always some fine builders in Europe and some builders, more of a craft type builder in America who were cutting lugs. But in about, I think in 2002 or 3, a guy named Kirk Vicente came up with the idea of introduced his own set of lugs. He was having them made in in Taiwan, there's a foundry there that specializes in bicycle lugs. It's called Longshen, and their workmanship is amazing. So Kirk Pesenti had worked for, he's a trained engineer, and he had worked for a bike company that wanted to make their own lugs. So he was the intermediary. He did all the technical work and had a relationship with Longshen. And then the light went off, and he said, I'm going to make my own lugs and sell them myself. So he did. And he consulted with particularly my good friend Peter Weigel, who I'll probably mention about 1,000 more times. And he introduced the Artisan series of lugs. And what's not shown here is there was also a crown. And it touched off, the idea of them was that they had a lot of real estate that you could sculpt into other shapes. And it really touched off a renaissance in lug cutting, in American frame building. And I should back up for just a second. Traditional steel frame building is on fire in America. This room, half the people sitting in this room are doing this stuff. And it's part of the maker movement. It's so exciting. Young 20-year-olds, 30-year-olds are jumping out of their skin with excitement to make these bikes. And a lot of them are addressing, trying to make it nicer than just take the lugs out of the box. So Kirk Pesenti, I take my hat off to him. He came up with these Artisan lugs. This is a lug in a lug vise, being an Artisan lug in my shop, being carved by me. And this, I think, is my first attempt at using them and my first attempt at lug cutting. And this is a good series of pictures. I'm going to jump through them quickly, but they show an uncut Artisan lug next to a lug that I have made into a little fleur-de-lis that I think is kind of attractive. There's many of these shots. Kirk Pesenti bugged me to shoot these pictures and put them on his website, and he never put them up. This shows, sometimes a frame builder who wants to cut lugs is unhappy with the amount of real estate on the lug that he can work with. So they weld extensions on, so they can fulfill their artistic vision. So this shows some kind of crudely welded on extensions. You also don't need to buy lugs. You can make lugs. And I think it was done on and off over the years, but a cat named Claude Butler was building frames during World War II in England, and he couldn't get any lugs. So he said, well, what am I going to do? He just started making his own lugs out of pieces of tubing. And he came up with a fancy name for it. Instead of apologizing for it, he called it bilaminated. This is an advertisement, and if you read the stuff, it's all him saying how great it is. And he sold it as an asset. Structurally, it's not an asset, but he was working hard for his money, so if he got extra, he deserved it. And he also had, I thought, a good eye. This is a cutaway of a Claude Butler frame, and some examples of his work, which, this is from the 40s and the 50s, and it's, it was an era when not a lot of fine work was going on, but yet he made these bikes. So it's one of the desirable marks today, Claude Butler. So these are a few shots of my own endeavors. I've done quite a few bilaminated bikes. What I have done, I've never done a full bilaminated bike. I do what I think the industry will call a semi-bilaminated, where instead of two pieces of tubing to form the lug, I just have a sleeve either around the top tube or around the head tube. And if people know a little bit about frame building, they walk up to it and they scratch their head and they like, I'm seeing a shoreline, but there's no shoreline over there. What's going on? And you can do some nice effects. And so I've kind of employed that on a number of bikes. So this shows the process. It's a piece of steel tubing that I've mitered and fit up. And another one that I've started to sculpt. These are sort of random. That's just a sculpted piece of tubing. Now I've tacked those pieces of tubing in place. These are some other bilams. That shows one that's kind of sculpted. Sometimes it's hard to file those little bits without, how do you grab them? So in this bike, like I tack brazed them onto the head tube and then filed them, and so you can grab the head tube in the vise. More. And that's kind of a more or less completed joint. So you see there's a shoreline on the down tube, but no shoreline on the head tube. This is the first bike that I did with Pesenti lugs. I was very timid about sculpting the shorelines. If you put them side by side, you would see that I did remove a lot of material, but they're just so recognizable as an Artisan lug. But the thing I want to show you is that top eye that I've created. I was messing around with my milling machine and a ball end mill, and I made 2 grooves, and I called it a double. There's such a thing as a fluted top eye that's got a concavity, but I made a double fluted top eye, and I thought it had a nice look. And I thought I had invented it, and then I was at a show, and a prominent builder named Brian Bayless said, "Oh, Jamie, these are magnificent. You did double fluted top eyes, just like Hetchins used to do back in the 30s. And I was, really? And I went through the internet, I found it. So he said, "Would you ever think about making me some?" So this is a show-winning bike with made by the late, sadly, Brian Bayless, with a Jamie Swan top eye. I made him 3 sets, and all those bikes are, the guys who own them will see me at shows and be like, "You made those double fluted top eyes, right?" Yes. This is the second bike I made with Pacenti lugs, where I always kind of thought a fleur-de-lis was a nice pattern. So I came up with this, and this is the bike that's in the display window outside. And I forgot to thank Thomas Donahue for doing such an excellent job of crafting the display window that I'm sure you all admired on your way in. That green bike is in the window. It was built 15 years ago, but I think it aged well. On that bike, I came up with a whole different style of top eye. I did this, again, on my milling machine. It just has 2 facets, and it's more simple, like a delicate little shape. The chainstays that it's on are double-tapered chainstays. They're fat in the middle, and they taper in both directions. And they have a very nice, light, delicate look, and I've gravitated to using those on all my bikes, almost all my bikes, since. And I came up with that shape, and this is the same bike without paint. I asked my buddy Peter Weigel to paint the bike for me, and he saw these things, and he said, "These are really cool. You got to come up with a name for these things." I said, "Yeah." He said, "I look like stilettos." And I said, "And stilettos they are." Hence, and he asked me to make him some, and he has used some on his bikes. Here's another pair, and I make them in batches. Once I had to make an oversized set, which was so annoying, and it's kind of because it took, if I make them in batches, I can make up a bunch of sets. But to just step off and get all set up to make one pair was annoying. For Eddie Albert, that scholarly guy. You're welcome, Eddie. Then I started doing more fleur-de-lis. This is my fleur-de-lis period. These are some more shapes that I refined from what you just saw. I thought they looked nicer. Now I don't like them so much. These are, the lugs are made out of stainless steel that's polished and then left unpainted. The traditional thing was to chrome plate some of the lugs and leave them unpainted. But now we have, Pacenti offers, many companies offer the lugs in stainless steel, so we can polish them, which is very labor intensive and annoying. But I did it for this guy, and I took this to a show in California and immediately got an order to make one just like it, except in the meantime, I had sort of changed, I came up with a very different shape for my fleur-de-lis. But this is that bike. This was the next one. It's still made out of a Pacenti lug, but I just feel like I was so pleased with the evolution of shape from that to that. I think it's good. I never saw this bike painted. The painter was in California, and the customer was in San Francisco. And it went from the painter to the customer, and he swore up and down he would send me pictures, and he never did, so who knows. The other one is in Mexico City, last I heard. So I'm moving ahead to another fleur-de-lis motif. This is a mark called Gloria, which was an Italian bike that I think stopped being built maybe in the 1950s, but a lot of top Italian frame builders came out of Gloria. Faliero Mazzi, Ernesto Colnago, Hugo de Rosa. So I always appreciated this motif. I thought it was cool. They put the fleur-de-lis on the side of the tube. It's really unique. Like no one has ever done anything like that. And many of the bikes were nickel-plated, where they left the lugs nickel-plated and the tubes nickel-plated, but they had those darts, they call them, that long point coming out. And I don't know, I thought it was neat. So I had occasion to build a frame for a good buddy of mine named Charlie Pellegrino, and this is my homage to Gloria. It's a bilaminated design, but a half bilaminated or half lugged. So I used that same fleur-de-lis shape, and I mimicked the the Gloria look. And that bike won an award at a big show. It had some critical acclaim, and I still like it. I mean, it's aesthetically, for me, this is over the top. I like something spare. The fleur-de-lis were over the top for me. I like shaker spare, but I was just challenged to come up with something interesting, you know. Grant Peterson says I have to make my bikes different, so I was making fleur-de-lis. On my next bike, and this is another double fluted treatment that I did with a wrap over. That was several weeks of work. I'm going to walk you through making that fork crown. That fork crown is all built up out of many pieces of metal. Making a fork crown out of 2 plates is very traditional. They're twin plate crowns. You see them going back through history. But this one I made from scratch. These are I made patterns to cut the shapes of the fleur-de-lis so they would be uniform. And these are the fleur-de-lis that went on the side of the fork tubes. These are the plates that I had to make a special fixture. The fork blades are splayed out, so you can't just bore those plates. You have to get them you have to bore them simultaneously, have them at the correct gap apart, and then drop a boring head in at the appropriate angle. So I had to make a thing to hold them at the right angle in my milling vise. There, the plates are brazed to the serotube. Now I've brazed on the fleur-de-lis, but the plates are this big, square, clunky, blocky things. And now I've sculpted them down, and there it is painted. So this is my next bike. I wanted to do something austere, and this bike was built for myself. I didn't have to impress a customer. So I just went for a simple lug shape, and some guys can do a simple lug shape. I spent hours sculpting that lug. It looks like I took it out of the box, but I spent many, many hours just refining the flow of that shape to get it just nice. I don't know how else to describe it. And I was really pleased with it, and it was like a revelation. Like, you just don't quit trying to impress people. Just build the bikes that appeal to you. So this bike had significant critical acclaim as well. This is it painted. The fork crown, of course, I couldn't just use a plain fork crown. This is a fork crown that I made out of an existing casting, and it's an homage to a frame builder called Joe Routens, who was one of the grand constructors of the Randonneuring bikes. This is a Routens crown. It's a plate crown, but the lower plate is arced, and it just bears against the inner side of the fork blade. It doesn't wrap around, which is a little daring. Like, aren't you afraid that's going to break? But the top plate is also curved. And I always thought it looked cool. When I saw this ugly piece of junk that came on the market, I immediately saw what I could do with it, and I started hacking it apart. I chopped the sides off it. I don't know if you saw that. I hacksawed it, and there should be some more images in there because I took away a lot more than that. But I got it down to that, and that's the crown in the jig, and that's the crown brazed, and there it is painted. And people went crazy over this, and I'm proud to say that many, many frame builders, some of them had the dignity to say, Jamie, do you mind if I pirate that? That's cool. Sure, go ahead. Oh, thank you. And then a lot of other guys did not. But when I see it, I say, I thought of that. Here's the bike complete. I'm sorry I don't have a better picture, but it was featured in that video that we saw, and it gained much further fame in the studio of Talia Lempert, a master of oil painting whose subject matter is only bicycles on a blank background with nothing else, just bicycles, and she has quite a successful career right here in New York City painting bicycle frames. Talia asked me to, I'm blushing. She asked me to borrow my bike. She'd been bugging me for years, and it came the occasion where I had to go in for a major surgery, so I didn't. This is my bike that I ride. So 2 days before surgery, I went to Talia's studio in Williamsburg, and I said, "Here you go, kid," and went off to get my guts hacked out. Talia painted 3 paintings. This one, I'm proud to say, is hanging in my living room. My wife fell in love with it. I didn't introduce my darling wife, Mary, and my children, Clementine and Amelia. Sorry, kids. Am I in the doghouse now? Mary loved this painting. She also loved that one. We couldn't decide, so she made me decide. This painting got picked up. Talia got approached by a company, an Italian publishing company that makes calendars, and said, can we go through your portfolio and select 12 images and make a calendar? And she said, yeah, go. They cut a deal. I don't know what the negotiation was. I'm sure she got millions. And they went through and selected 12 images, and this was one of them. And in fact, this was the featured one. When you went to buy the calendar, it was wrapped in Mylar or whatever, plastic. And this was the one on the outside. And that was a big kick for me, and I guess Talia liked it too. It was a nice thing for our friendship. Okay, so off to another crown. This is kind of an oddball thing. I made a crown out of 2 crowns. The one on the right is the ugly one that we talked about earlier, and the one on the left is made for a different, there's 2 shapes of fork blades. The imperial oval is you can see the shape difference. The imperial oval is the old traditional thing, and the one on the left is more modern. One of those crowns, the upper one, accepts the imperial oval. So I wanted to do that same thing again, but the crown didn't accept the imperial oval. So I had to brainstorm. I'll buy the crown that does accept the imperial oval and use that for the top plate, and the lower one that's getting all chopped away, it doesn't matter what it fits. So I started hacking again, and I put it on a lathe and machined it a bit and a bit more. And then I took the other crown and I stuck it in my mill and started chopping away, chop, chop. And this is just an initial fit up of the marriage. You can see that they're both quite rough. But then I refined it some more, and refined it some more, and refined it some more, and pinned it together and raised it together. And there's the finished crown, and that's on that bike right there. And again, the people who really go nuts, the lug huggers who go nuts over all this stuff, we're very, very impressed with that, and quite pleased. And I see people now on the internet chopping apart 2 crowns to make one. I would never do it again. It was idiotic. Another bike, this bike goes back a little bit, but this is one of my favorite bikes. This is an unusual circumstances because I started off racing bikes. I was particularly good at, well, I don't want to say good. I was better at track racing than road racing. And my first bike that I built was to race on the Casino Velodrome in Queens. And I kind of designed the frame specifically for that track. And it was very successful. It worked really well on the track. And I put all this nonsense on my website. And this young man approached me at a party, a bike party, and said, I'm a track racer. He was 25 years old. I'm the New York State track champion. And would you ever consider building a bike like that for me? People are not racing on steel bikes, lug steel bikes. They race on carbon fiber. And I was smitten, and I said, I don't know how much this kid can afford, but I'm going to give him a cheap price because I want this project. So I built this bike, and it's very plain. To keep the price down, I spent a lot less time on the details, but I don't know, it just has a very nice look. I really like the bike. And here is Mark Wagner racing on Casino Velodrome. He's an elite rider. He's traveling around the country. Here's a picture of him on a board track up in Canada, on the Winter Board Track Series. And he not only has he won the state championships, but he has won the heart of my daughter, Amelia. Pretty cute, right? Okay, so I want to talk about randonneuring bikes. I'll try to be quick. I'm sure we're running short here. This is an illustration from Daniel Rabor. The randonneuring bikes are a style of French light touring bikes. They're not designed to carry a lot of weight. They're not intended to go camping. It's a style that evolved during and after World War II, where the French, there was a little more leisure time, and they had started to become popular to ride out into the countryside and picnic on the side of the road. And this style of bike evolved. They had a lot of built-in things like fenders, integral lighting systems, a front rack to carry a bag, some other things that I'm probably not thinking of. Carrying a bag on the front of a bicycle, if you put any weight in it, it's normally a bad idea. It makes the bike steer horribly. But the French builders of that era came up with a type of geometry called low trail that modern frame builders would look at this geometry of the front wheel and say, this is unrideable. But if you put a weight on the front handlebar, all of a sudden it disappears. You don't even know it's there, and you can put a lot of weight on it. So it was like a brilliant thing that the constructors of the randonneuring bikes in France in the 40s and 50s.
Another Rabor illustration, a Rutten-style front rack, and you can see a little bit of that Rutten-style crown. My good friend Peter Weigel, who is kind of the master, he's the king of randonneur bike building today. I don't think there's anybody who would say that he isn't the top dog in the world. He has made his own vision for a Rutten-style rack, but it's very elegant. And he invited me up to his shop in Connecticut to build. This is the rack that's on that bike. And we worked on it together. And it was kind of a nice collaboration because there we are with our diacro tube benders. I guess you know which one is which. I built these, the way Peter was bending the tubes was kind of crude. And he has machine tools, but he openly admits he's not a machinist. So he helped me make the one rack. Well, I made a complete set of bending dies for him, which would be thousands of dollars worth of equipment, but I made them in duplicate. I made a set for myself and a set for him. And he's now loving using these radius collars, follow blocks, clamping blocks. Here is one of those benders blocks in action. Here's Peter's hands brazing together that top platform. Another thing that these bikes have is integrated lighting. I have made my own tail light that's on that bike. There it is. The internals are pirated from an available commercial light, but the housing was designed and machined by me. So that's just one of the little things. The bikes typically have a Dynahub, a front hub that generates electricity, and this is a Schmidt Dynahub that's kind of the top of the line. The electrical connections between the hub and the bike are through the axle. These are the front dropouts, special front dropouts with connectors, so one side is positive and one side is negative. And here's my fork in process where I've brazed a very skinny stainless steel tube inside the fork blade to route the wire. And now it pops out and then it sneaks through the cantilever boss braze on and then sneaks into the rack. And that's kind of the complete setup. The pump is not a normal pump. It's heavily modified, and I had to make the pump pegs. One of the cables goes right through the pump peg, which was a huge pain in the ass. The brake bridges and the chainstay bridges are designed to hold the fender. The distance from the center of the axle to that surface has got to be exactly right so that the fender line follows the wheel gracefully. You don't want it to be all lumpy. To make those, I had to make another set of dies to get the radius I wanted. And here's the brake and chainstay bridges ready to go in the bike. And here is the bike with the rear fender installed. We make the stem, fillet brazed out of chromoly tubing. We make the decalor de sac. It's a device that holds that front handlebar bag from the top, and you'll see it that is for that bike. It's right there. The bag, you can't just rest it on the rack. You kind of have to hold it up. So the French constructors did that. And there it is in place. Probably the king of this stuff was a cat named René Urs. And he was an aircraft mechanic and a machinist. And not only did he make brilliant bikes, but he made a lot of his own. He made cranks and stems and derailleurs and his own brakes. And all that stuff, it's almost like the pinnacle of collectible vintage lightweight bikes now. René Urs is one of the top names. The French had a name for the builders of these bikes where you had to do so much more than just build a basic frame. It was like 2 or 3 or 4 or 5 times, I don't know how many times more work to integrate all these other systems. And so the term that I've been using it here tonight, they would call him a constructor, and it connoted a frame builder, somebody who was a notch or 2 or 3 above just a frame builder. So I certainly have not achieved that title yet. I have built one randonneuring bike, but I'm really pleased with it. Here it is Mary and I went to Cape Cod, and we're riding around having a good time, as you can see. I entered it in a show, and I'm proud to say that I won first place. I climbed Pilot Mountain in South Carolina with my brother-in-law, Steve Tatter. And Peter and I did a 4-day bike tour out on the east end of Long Island, which I named the Twin Forks Ramble. We did the Deerfield Dirt Road Randonnée together, and here is me crossing the finish line triumphantly. And I'm done. I hope for...
hope I haven't put anybody to sleep. If I have, I'm sorry, but it's time to wake up and go home to bed.
Any questions?
Oh, yeah, questions. Yes.
When you're changing the shape of the lugs, are you doing that with a saw? Are you using a plasma cutter? What do you, I don't get that.
It's for the film.
Did everybody hear the question? When you're changing the shape of the lug, what tool do you use? Mostly files. Some guys will use a jeweler's saw. You can employ, I mean, sometimes you put it on, you can drill a series of holes. You know, it's kind of like do what you need to do to get the shape you want. So sometimes you have to resort to other means, but 99% of it is done with a file. Okay. Well, the maestro, Jean Weir.
How do you braze stainless steel lugs?
It's a good question. It's always done with silver brazing wire, never brass. And I'm not sure why, but that's what they tell me, so I obey. It's the same exact process, but we use a different flux. The typical flux that we use for, I don't know what the formulation is, but the flux for silver brazing is white flux, and they use black flux or a combination of the two, gray flux. And you have to, I skipped over the fact that when we braze metal together, you need to abrade it with typically emery cloth to get off all the oxides, and wipe it down with acetone to get rid of dust and dirt and any residual oils from your hands. So we do that normally, and we do that very, very carefully so that to ensure the maximum integrity. But with stainless steel, the stainless apparently like micro oxidizes quickly when you abrade it. So what you want to do is be really, really conscientious with your prep, and then flux it and braze it immediately. But otherwise, once you've got the torch lit, it's the same. Thank you.
Jamie, thank you so much. That was fantastic. It was so comprehensive. Your eloquence and enthusiasm, and one word kept sort of striking me all the way through: precision, absolute precision. It's absolutely wonderful to see someone so devoted to your craft, and I think you so clearly communicated that to everyone here. We are thrilled that you could be part of the Artisan Lecture Series, so thank you so much. Thank you. And for those of you who maybe have not been here before, it is typical at the end of our artisan lectures that we make a presentation to the artisan. And again, I'm going to reintroduce you to Victoria Dengel, who's going to present Jamie with a citation.
And Jamie, yes, thank you. I mean, the passion that lives within you, it makes me excited to go. I haven't rode a bike in years, and I'll never look.
It's time.
Now all we have is this native New Yorker city bike, so now we'll be looking at more of your images, and thank you so much for your contribution to the General Society Artisan Lecture Series. You are a true master artisan, so thank you.
Thank you.
Thank you. So on behalf of the General Society of Mechanics and Tradesmen of the City of New York, founded 1785, we express our gratitude to Jamie Swan, bike maker, building modern bicycle frames using traditional methods and materials, for his participation in the General Society of Mechanics and Tradesmen Artisan Lecture Series. So thank you so much.
Thank you.
Thank you.
Is this on? I probably should have said earlier that I'm not a professional frame builder. I've been messing around with this for years. I've just never had the nerve to take the plunge into it as my vocation. And there are hundreds and hundreds of guys, many of whom are sitting in this room, who have been toiling for years in the trenches, doing battle, trying to earn a living, building a bike. Building bike frames is very difficult to do. My hat is off to them, and I accept this on behalf of our community.
And well, we really never let our presenters go. So we have made you a lifetime member of the General Society
You
Library.
beat me to the punch. I was about to sign up.
And Meg Stanton will present you, our
Hello.
program
Here you
coordinator.
go.
I get to
Yes.
keep this as
Yeah.
well?
Yes,
Oh
yes.
Wow.
And finally,
It doesn't
a
end.
keepsake.
In the bag.
Yes.
Thank you.
Thanks so much.
you.
Thank you
Thank you.
all for coming out.
Thank you.
Good night.
Thank you to everyone who.
Yes.